Welcome to our Xamarin University course using ListView in Xamarin.Forms. My name is Renee, and by the end of this course you will know how to utilize a ListView in your own Xamarin.Forms application. The general idea of a ListView is that we want to display more data than fits onto a single screen. The available space on a mobile device is limited, so we have to come up with a strategy that allows us to scroll content. ListView does exactly that. It provides a scrolling container for what we call rows or item. As you know, every control that we have in Xamarin.Forms is mapped to a native UI element. In case of iOS, that would be a UI table view. For Android, it will result in a list view, and for the Windows world, it's also called list view there. The rows inside a list view, they are interactive. So you can not only present data, you can also react to input like tabs, or you can have advanced features like context-sensitive actions. In order to get your data into list view, you do not call any specific methods like add row or insert item directly on the view. Instead, list view relies on an item source. That source can really be anything that is enumerable. So this means you could use the result of a link expression. You can use an array, a generic list, but also, of course, an observable collection, which we will look at later. To set the item source, you can either use code, as can be seen here, setting the item source property, or you can, of course, do this in XAML. In this example, here you can see how the item source is set to a static resource. Of course, data binding is something that you could use in here too. The moment we have set up a source, ListView will talk to that source and will ask how many rows are there. And then for each and every row that is currently visible on the screen, ListView will perform a process that's called inflation. That means it's going to take the information for every item in your item source and transform it into something visual. If you don't add any specific instructions, that inflation process will call the toString method on your source items and turn the result into a label, which it will then display as part of the list view. This takes us straight into the first exercise. In this first exercise, you will work with a small application that we have prepared for you and then add a list view in order to display some items. I invite you to do the exercise now and then come back and continue with the video. I will start reviewing the exercise in a couple of seconds. Here's the completed solution of exercise number 1. You can see it running here in the iOS simulator mirrored to my Windows machine. It displays a list of countries as instructed by the exercise instructions. If we look at the XAML behind this page, we find that there's simply one list view in there, and we assign an item source. That's really it. We don't have to do anything else. This alone will get us something to the screen. However, this only works because the flags that we bind to these objects, they override the toString method. If we look at our model object, which we have here, and scroll all the way to the bottom, we will find public override string toString. This returns the country, which is a property of our flag object. If we don't have this override in there, the list will simply tell us that each of the objects, well, that's a flag object, which is not very helpful. The next step will now, of course, be to customize that a bit. The first part of our list view customization is not so much about the UI, it's about handling interaction. What we have right now is a list view that does not react to any user input. Now, let's face it, how often do you have an app where you simply show a list of something and nothing's going to happen? Exactly, never. We want to support selection in our list view, and we can do this by leveraging the selected item property or by using an event that is exposed by a list view. The nice thing about the selected item property is that it works two ways. We can set the selected item to one of our objects. In our case, in our exercise, that would be an instance of a flag object. And we can read it in order to get the currently selected item. So if our users, they select something, they change the selection, this property will be updated. Of course, this is data bindable. That allows us to directly react to a change of the selection. For example, we could data bind to a property in our binding context, maybe that's our view model, and then store the currently selected item, or we could trigger a navigation directly from within our view model in case the selection changes. An alternative approach that works just as well is the event-based one. ListView exposes two different events. There's item tapped and item selected. Item tapped is something that will only trigger if the selection is initiated by the user, where item selected is something that gets triggered in both cases, if initiated by the user, but also if you change the selection programmatically. The other minor difference between the two is that item tapped will be raised continuously. Even if you select the same item again, you would get another item tapped event for that item, but you will not get a new item selected event. The signature is pretty much the same. They both give you the sender, which is the list view, and you get either item tapped event arguments or item selected event arguments. Both of them contain the current selection. By using the item property of the event, you can figure out which of your elements has just been selected, and then maybe, as you're shown in this case, trigger a transition to a new page. We can dive right into the second exercise, where we want to add this new selection behavior in order to get back the full functionality of our flags app. Just like before, I will wait a couple of seconds, give you a chance to switch over to the exercise. Maybe you want to pause the video here and then go back and we will review the completed exercise together. We are back in Visual Studio. In the code here, you can see how our list view now is using an item tapped event in order to handle input from our users. I'm running the app here again in the iOS simulator. I can select a country and it takes me to the correct target screen. I can go back and notice how the selection is still there. Let's pick another country and we go back. The event handler responsible for this operation is in onItemTapped, which can be found in the code behind of our allflags.xaml file. Here it is. The event handler can be private. You don't have to make it public. In this case, it is modified with the async keyword because we want to trigger a navigation, which is an asynchronous operation. In our case, we simply push a new flag details page onto the stack. We don't have to pass the current selected item to that details page. It's going to pick it up automatically. Commented out, you see here an alternative version where the current selected flag is retrieved from the arguments that we have here. It's the e.item property. Of course, this also works on other platforms. Let me demo Android to you. Here the application is running on my Android device. I can navigate just like I can do it on iOS. Go back. And we have a native Android list view here. With that, let's go back to the slides. A list that allows selection is a lot better than a list that is just static. But even better is a list that allows changing the current content. It's very common that in an application, you must be able to add new data into your existing list view, to remove something that is in there, to change the contents of one item, or to move an item to a new index. Because ListView does not have any methods to directly manipulate our underlying data, we have to work with the collection that is used as the item source for the list view. Let's have a look at these examples here. Here are our list views. It would show items from our recipes collection. We can, for instance, add a new recipe. We could remove one. Here it's the one at index 0. Or we could change one that is currently in the list. Here we are setting it to something new. It would also be possible to just change a property of one of the existing items, or to move one item to another index within the list. The problem with this is the list view will not react to our changes. No matter how often you call add, remove on these recipes collection, or no matter how often you change something, the visualization state, that will always stay the same. So we need to find a way to notify our list view. If you think back to our data binding class, we learned about an interface that is called iNotify property changed. We had to implement this interface on our source object in case we use bindings, and that will inform the binding engine that it has to re-evaluate the source value. There is something very similar for collections. It's the iNotifyCollectionChanged interface. It has got one single event in there, which is the collection_changed event, and it takes collection_changed event arguments. Instead of implementing this interface directly, we typically use one of the existing types that is implementing it for us. The most common one is the observable collection of type T. Look at this example, please. Our recipes, that property is still exposed as an iList. Internally, however, we assign a new observable collection. The list view does not check for the exact type. It just verifies that whatever you expose there is an iNotifyCollectionChanged. Well, that's the case here. This allows you to keep the observable collection as an internal implementation detail. You can change it if you need. If, for instance, you look at our Xamarin University infrastructure library, you will find an observable collection that supports batch updates. To the external world, you simply return the type that you think makes most sense. Often that's an iList. Now, if you change the underlying content, the list view will be informed about changes and it will reflect those changes visually. We have an exercise about this part. Please have a look at it. You can continue with the results of your previous work. Pause the video here, and when you're done, come back. We'll have a look at the completed exercise. Here's the completed application, this time running on UWP. We again start with our list that could use some visualization improvements, but we'll get to that. But the more important bit is now that we can switch this list into an edit mode. Well, up here we have this little icon. I can edit in here. And now if I select one of the countries, just pick one of them, it asks me whether I want to remove it from the list. I can confirm with yes. And notice how the country has been removed. Let's have a look at the code. In here in our XAML, we use the item source attribute and data bind it to a flags property. If we switch back to the code behind file, we'll find that the binding context, that is our funFlags view model. So let's have a look at that. We should find the flags property in there. Here it is. Notice how this is exposed as an iList of flag. No word about an observable collection or anything like iNotifyCollectionChanged. However, this is talking to our repository. Our repository has got a flags property too. So let's check that out. Here, our flags property is generated from an observable collection. We just load all the flags from our database and put them into this collection. If I jump to the property up here, you see that again, it is not exposed as an observable collection. However, if ListView, it talks to this flags property and asks, hey, what are you? Are you an iNotifyCollectionChanged? It will answer yes, because internally it is an observable collection which implements that interface. With that in place, we can now change our list. We can add new items, remove them, and the list view will update accordingly. If you run this application on iOS, you will even see how the list view animates those changes. Changes in your list view may be the result of the user manually adding some rows or removing them. However, there's another very common scenario. And that scenario means that something in your application is trying to change the collection from within a background thread. Imagine an application that is talking to a web service that finds the cheapest flight to a specific destination. So you let your users enter a destination airport, the app reaches out in the background to your server backend, and whenever it finds a new result, it wants to change what is shown in the list view. And we have to make sure that these changes occur on the UI main thread. Now wait a minute, you might say. Am I changing the UI? Well, if we look closely here at this example, we don't really spot anything that would touch the UI. But keep in mind that whenever we change our item source, it will affect the UI. So that's why we have to make sure to call device.begin invoke on main thread to marshal that call back to the main thread. And yes, this is different from iNotifyPropertyChanged. If you change a property, it's perfectly fine to do that on a background thread. Xamarin.Forms will take care of marshalling to the UI thread automatically. However, with collections, that's not the case. This method here, using device.begin invoke on main thread, is what you will use, I'd say, 95 or 99% of all times you need to change the collection. However, there's another situation. This is really meant for more advanced scenarios. Let's go back to our example that searches for cheapest flight prices. What if you don't reach out to one single web service, but to multiple web services in parallel? So you have 3 different background threads running, and whenever one of them receives a new flight price, it wants to add it to the collection. And the collection is what you use to visualize content in your list view. And maybe that list view is interactive. It allows removing, adding rows. Maybe the user can do that manually. So in other words, everybody is trying to change to write to that collection, and the list view just wants to display it. This can be a problem because there's a chance that one thread, it writes to the list view, the other one wants to write at the same time to the same location. The list view is maybe at the very same time evaluating the collection, and then when it's trying to access the collection, the number of items has changed and your app will crash. To synchronize all of this, Xamarin.Forms offers the binding base that enable collection synchronization method. To this method, you pass as a first parameter your collection. This is what backs your list view, and this is what all of your threads want to write to. The second parameter here is optional. This is just some user object that you want to have available whenever the list view tries to access your collection. We'll see in a second where this is given to us. The third parameter here is a delegate. And the list view will call this delegate every time it wants access to the underlying collection. And the parameters of this delegate are now the list itself, the context, which is the parameter that in our example is null, so that's the user object. The third parameter is another delegate. This action is what the list view is about to execute. And the last parameter is a Boolean, where the list view tells you whether it wants to write to the collection or just read it. So why are we doing all this? Well, because you can now implement some sort of locking. Here in this case, we just lock some object. And when we are sure that we are the only ones who have access to the collection, then we call this delegate that Xamarin.Forms is giving to us here. Of course, you will have to use the same locking mechanism in your threads, which also contribute to the content of the collection. Like I said, this is a far more advanced use case, and you will mostly be fine by using the previous example where we just marshal back to the UI context. Let's do a little flash quiz. Question number 1. If you intend to alter the collection providing the data for a list view, you should use what exactly to make sure the UI is notified about the changes? Is that A, a list of T, B, a notifiable collection of T, or C, an observable collection of T, or D, is it just that any collection type will work? That's, of course, the observable collection of T. An answer that is not in the list here is iNotify collection change. That's the interface that we really have to implement. But from the types offered here, C would be the correct answer. Number 2, to add a new item to the list view, what can we do? A, call ListView.items.add, or B, call ListView.itemSource.add, or is it maybe C, just ListView.add, or is it D, none of the above will work? The correct answer here is D. All of these options are wrong. The one that might be tempting is answer B, itemSource.add. What if my item source is, let's say, an observable collection, which clearly allows adding objects? Well, remember that item source itself is just exposed as an IEnumerable. And an IEnumerable is read-only. So there is no add method on item source directly. You can, of course, cast your item source back to the observable collection, and then you would be able to call add. But directly as it's shown here, that's not possible. Let's get to another very popular feature. And the idea is that instead of having a button that you press to refresh the content of your list, or to perform some other option, like maybe change the sort order, you would pull down on the list and then let go. And this will trigger some action. This feature is built into Xamarin.Forms ListView, and here you see how it is visualized on iOS. In order to enable this feature, you would set the isPullToRefreshEnabled property of ListView to true. It is false by default. We can do this in code, or we can do it in XAML. The second thing that we need then is some sort of callback. So there is the refreshing event, which you see implemented here. Please note that when you reach the onRefreshing method, you are on the UI thread. Refreshing content of a ListView typically means that it's going to be a longer running operation, like talking to the database or reaching out to a web service. So you want to make sure that you run asynchronous code here, or maybe use another thread. So you have new data, and you want to disable the UI that indicates our users that the refresh process is currently going on. And you can do this by simply setting the isRefreshing property back to false. If you're a fan of the MVVM design pattern, you can also use an alternative property to be notified if a refresh gesture has been detected. The ListView supports commanding. There's the refresh command property that you can data bind to a command in your view model. It will respect the canExecute method. That means the refresh will only be allowed if that returns true. You can also data bind the isRefreshing attribute and set it to false to turn off the refresh logic. And this supports two-way bindings, so it will work both ways. Finally, there's one more option. There are situations where you will want to trigger the refresh process from within your code. And you also want the visualization of ListView to be visible. In this case, you can manually start it by calling begin refresh, and when you're done, you simply call the ListView's end refresh method. We have a little demo here, or should better say a group exercise, where I will show you what pull to refresh looks in action. Let me switch over to Visual Studio. If you want to, you can also pause the video here and try to do the exercise on your own. We are back in our application, running it on iOS, and I will try to pull the ListView here. You can see how this indicator appears, and if I pull down far enough, it will start to rotate, and if I let go, the order of our flags, of our countries in here has changed. It's now ordered descending. I can try again, it will be sorted ascending. And I doubt this is visible in the recording of this here, but if you try it yourself, you will see that while it is sorting, the ListView will actually animate. If you look at the code behind, you find that we have implemented an onRefreshing method, which you see here. It just runs through the collection and it sorts them. And to slow the sorting down, we have a delay in there. So whenever it's changing an item, it waits for 200 milliseconds. And this gives ListView a chance to update and visualize the change with a little animation. Of course, we did this on purpose. Please don't go ahead and add tasks or delays to your productive app. If we look at the XAML, we find that the isPullToRefreshEnabled property is now set to true, and we assign the refreshing event handler here directly in XAML. Alternatively, we could have done that in code too. I know you're still waiting for the customization of the ListView rows. I promise that we'll get back to that. Well, let's have a look at it now. Currently, what we see in our ListView is the result of the inflation process that by default generates a label from our data by calling the toString method on our objects. This can be acceptable for prototyping, but really, it's not beautiful. There's another problem with this approach. Even if you say, I'm fine with this label that I have there with the default visualization, try changing one of the properties of your items. you will notice that the change will not be reflected in the list view. The reason for this is that what gets generated here does not observe the iNotify property changed event. So changes will not be visible. We can fix both the visual aspects and also the property change problem by providing a custom layout. ListView supports fully customized layouts, or you can use one of the built-in styles, which is what we will focus on today. Our ListView has got an item template property, and it contains the instructions that should be used to turn our model into something visual. These instructions can be assigned either in XAML, which is very common, or you can do it in code. The built-in styles that are available to us can be seen here. We have the text cell, which renders some text, plus with smaller font, some detail text. We have an entry cell that shows an editable text field and a label. Up next is the switch cell, which contains just a label and a checkbox. And then we have the image cell. This derives from the text cell and adds an additional image on the left-hand side. All of these have something in common. They are cells. Cell is an abstract base class they all derive from. There's actually a fifth one that is not shown here, which is called view cell. View cell is just like a blank sheet of paper. This allows you to provide your completely customized layout. It is something that we will discuss in the follow-up to this course here, where we talk about the more advanced features of ListView and also about performance optimizations. Today, we want to use the image cell because it perfectly fits what we need for our demands. We will display our flag icon, our country icon on the left-hand side, show the name of the country and additional details. Here we see how a text cell is used as the item template. Item template is the property of ListView that we use. It accepts a data template as its type, and that data template is wrapped around our cell. Something interesting happens with regards to the binding context. It switches automatically to the currently processed item. So whenever you use the binding extension and you have a property name there, that property name can be found on the individual item. In our case, that will be a flag object. Here, in this case of the example, it is a recipe object. An alternative approach for applications that have more dynamic content, where maybe we don't know ahead of time what the visualization will look like, we can also create our template directly in code. Here's an example how to do that. You would just say that the data template is one of the existing cells. It's a built-in one or a custom one. You would then set up the bindings manually, and if you want, you can also change certain aspects of the existing cells, like here we are setting the color of the detail text. Finally, we assign everything to the item template property. There's a variation of that. Maybe you want to keep all of the bindings and the setup of your cell nicely within one class. So you could derive from an existing cell type and put your code into the constructor. Finally, there's the possibility to use a delegate in order to create an instance of a cell. This can be useful if you need to provide additional parameters to your cell-derived type. However, this does not allow you to create different data templates or different cells for different rows of your list view. Having different visualizations on a per row basis is also possible. However, it's a more advanced feature which we cover in the follow-up to this course. Before we get to the next exercise and talk about customization a bit more, here's one more flash quiz for you. Question number 1. Data templates can be defined in code or XAML. Is that true? A or false? B. That is of course true. We actually saw 3 different ways of creating them in code and we also have seen a XAML example. Number 2. For ListView, the data template must define which type? A view, B, a visual, C, a cell, or D, a view cell. The correct answer here is C, cell. View cell is just one specialized type that derives from cell. The built-in types that we have are text cell, entry cell, switch cell, and image cell. The next question is about the built-in cell types. Which of these is not a built-in cell type? Is it A, text cell, B, image cell, C, slider cell, or D, all of these are available? That was easy, right? Because I told you in the previous question. That's of course the slider cell. Text cell and image cell are both available, but there is no slider cell. Bonus question. What would you do if you wanted to have a slider cell? That is a cell that contains maybe some text label and a slider. Yeah, absolutely right. You would create a view cell. And into that view cell, you would put the label and the slider control. Once again, it's exercise time. Please switch over to the lab instructions and work on the next exercise, where you will learn how to customize the content of the list view. When you're done, please come back to the video. The completed exercise is running on Android here. And we can see now the list looks a lot better than before. We have our visuals here, our images, we have the name of the country, and the date the flag was adopted. You can see how the selection still works as before. We have one row that is highlighted here, and of course I can navigate. I just select Brazil here, takes me to the detail screen, and I can go back. We want to try out what we said about changing properties in our objects. So if I just pick Denmark here as an example, and I change the date when it was adopted, maybe from, I don't know, the 1st to the 11th, submit, and we verify here that our model has really been changed. We see now it says 11th, no longer 1st, but now I go back. I think we should be able to see that in here it now says the 11th of January. It's pretty hard to read. Let me select another country so it updates. And we go back, then you should be able to see it a bit better. Now I think it's clearer. It has updated itself to 11. This would not happen if the default inflation process is in place. Code-wise, if we look at our XAML, we are generating an image cell in here, which we wrap with the data template element, and we assign that to our item template attribute. We can configure certain aspects of this image cell, like the detail color, and then we simply data bind to properties of our current item. Like here, the small image URL, the country, date adopted, all of these are properties of our flag type. And of course, these bindings support the same converters that we can also use outside of these cells. Now you're already pretty close to becoming a ListView superhero. However, let me talk about a few more little tweaks that we can use with ListView. The first thing here is that we can change the separator. Between the individual items of a list view, we find a line. On iOS, it's by default a very thin gray line, and on other platforms, it might be more or less visible. We can influence that separator by setting the separator visibility property to none or default. There is no option for always at the moment because not all platforms support it. If it is supported on a platform, you can change the color. Another really nice feature of ListView is that it supports context-sensitive actions. Here you can see what they look like on iOS. They allow you to swipe from right to left on one of the items and then reveal options. These options, they can allow you to delete something from your list view, to send something. You can trigger whatever action you can imagine. On Android, these objects, They become visible by performing a long press on the row. Context actions are nothing but menu items that are assigned to any cell type. So you can use this with the built-in text cell as shown here, with the image cell, or with your customized view cell. Every menu item provides a clicked handler that will be called in case the item is selected. You can use a text that will appear as part of the context item. And we have this optional isDestructive attribute. If this is set to true, it will render the context action in a more signaling, so more significant color on iOS to indicate that user is about to perform something that will destroy or delete data. The handler for context action looks like this here. The challenge is to get access to the item where the context was selected from. It might be tempting to just use the selected item here. However, that's not necessarily the item that the context actions is being called from. You can select an item or change the selection programmatically and then swipe on a completely different item to reveal the context actions. The best way to get to the current item is to use the binding context. Remember, we learned that the binding context switches to the currently processed item. And you can just cast that back to, in this case, a recipe, or in our example, to a flag. Everything's a bit easier when using the MVVM approach because the menu items, they support commanding. So you would data bind to some command in your view model. And by using the command parameter, you can easily provide information about the item that was selected. If you just bind that to a dot, that means the current object will be given to your command in the view model. We don't have an actual exercise about the context actions, but you will find some information in the lab materials. And I invite you to do this as kind of a homework. So open up the solution or continue with the one that you have worked on in the previous exercises and try to add these context-sensitive actions. If you have any questions, please reach out to us via the Xamarin.Forms. And now we have already reached the end of this course. I hope you enjoyed it. Thanks for watching, and goodbye.